Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you wherever you are, whether in India or outside India. And as you know, this is a course which is titled DADM 2, which is Data Analysis and Decision Making 2 under the NPTEL MOOC series. And this total course duration, as you all know, which I do repeat in the starting of each class to make you aware where we are and how we are proceeding. This is a 12-week course. Total number of lectures is 60 in number, that is 30 hours, because each lecture is for half an hour. And as already mentioned, and as the plan is, we complete 5 lectures each week. Each again I am repeating, is for each of those lectures for half an hour, and after each week we have assignments. So, and my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you can see in the slide, which is the DADM 2, which is lecture number 42, which is in the 9th week. That means, we are in the second class or the second lecture in the 9th week. So, we were discussing about general concepts of we will discuss something to do with dominance, then first order, second order, also consider different type of Pareto optimality. I did mention about what Pareto optimality in a very simple sense. Then we will consider the simple properties of MAUT, which is multi attribute utility theory based on utilities, which are based for different attributes, and we have multi criteria under on attributes. So, there are different attributes based on which we find out the utility and try to find out the conglomeration of all of the utility functions based on attributes, such that we can take a decision whether alternative 1 is better than 2 or 2 is better than 3, and all so on and so forth. And we will next we will also consider the very simple concept of concept wise what is multi objective optimization or multi criteria decision making, and we will only give you the feel of the problem, because these concepts in more details would be solved under the DADM 3, where we will consider the main focus would be in the area of optimization and operational research. So, whenever you are considering MAUT, which is multi attribute utility theory, we consider the weak Pareto optimality. So, consider there are sets set S X. So, X has different elements, and each elements are of dimension n, or whatever the dimension is. That means, if you have x1 which is an element of x, x2 which is an element x, whatever the x values be, we consider the x1 or x2 or whichever x is an element of capital X is a vector, and each of these elements in the vectors values in the vectors correspond to different type of attributes which accrue from any one of the criteria corresponding to the fact that what is the overall value net worth you will get by taking that decision x1 or x2. So, the elements of x1 or elements of x2, which I have already said, I am again going to repeat that some of them may be attributes, characteristics which are not easily discernible as quantitative values. They have some subjectivity into consideration, other part would be the objective criteria which can be quantified. So, let me continue reading it. So, if amongst those x1, x2 till whichever x value you take, if you have some x star, so it will be and it will be called, that x star would be called a weak Pareto optimal if there exists no other vector x from that capital X value, such that the overall functional relationship of, say for example, you are taking different type of the functional forms. So, there is in each of the dimensions the functional forms are such that the values of x1 or at values of x1, x2, x3, x4 is less than equal to the value of the functional form at x star, so on and so forth for each and every functional form. So, if there does not exist any other vector x, if this is not true, then we will basically say is weak Pareto optimality would be there. That means, the relationship between the x star and the other x's would not be absolute in the sense there is no dominance on all the aspect, but there would be some dominance or some non-dominance such that the combination how you are going to find out which is more dominant and which is less dominant, based on which you will rank them, may not be clear to you. So, and the objective function which you find out based on the fact when you take the decision of x star, or you take the decision of x 1 or you take the decision of x 2, that will be denoted by z. So, corresponding to x 1 or x 2 or x 3 or x star, the corresponding z values would be nomenclatured accordingly, that is z 1, z 2, z 3, z star and so on and so forth. So, this would be called the weak Pareto optimum solution if the corresponding vector x star which you have already defined is weakly Pareto optimal, and if the set of weakly Pareto optimal solutions can be found out, they will be clubbed as a weakly Pareto optimal subset of the capital X. So, you will basically technically you should have some sets of x where the overall combinations for different values of the vector values which you have, if the overall utility which you are getting from the utilization of those particular x's comes out to be the same, they would be Pareto optimal, and in some of the cases if some of the subsets gives you a value for or the utility based on those some sets of x is non-dominating and is less than equal to or is more than equal to, whatever the case is, as you change the combination, you will basically have different weak and strong optimality considerations based on the Pareto optimal solution. That means, if I have a car and consider the car is brand A, another car is brand B. I am only considering car A and B, there can be other brands also. So, consider that brand D is the best. So, in case brand D is the best, so in that case if you consider each and every criteria, attributes, whatever characteristics you are taking, they would not be the overall brand values, the values which you are getting for the brand D would not supersede or would not be more than the any of the individual combination of A, B, C, E, F, G, H, whatever you have. And if they are equal, like say for example, D is equal to G, in all the accounts for different combinations we will say that they are Pareto optimum solutions, or whether you take D or G, the overall net value which accrues to you as a decision maker are the same. Like you have a budget of 100 rupees as I said, and you want to buy different things, it can be rice, flour, wheat, some vegetables, and if you get and you are trying to compare them with respect to say for example, the nutrition values, protein values or calcium values, carbohydrate values, whatever, and you have combined them in different proportions. If you get two basket of such goods based on the concept of funding constraints which you have 100 rupees as such, if the overall functional values based on nutritional facts are the same, they would be optimum solutions, Pareto optimum solutions, so that whether you take one set or combination of one set of food items with respect to the other set of food items, they will give you the same worth. So, this worth depends on whatever utility function you are trying to use. It need not be money, it can be nutritional values, it can be net worth, whatever you want to assign. Now, we will consider the concept of stochastic dominance. So, which you have discussed the last day, but I am still repeating it, please bear with me. So, the first order stochastic dominance would mean when a lottery. So, lotteries are basically some uncertain decisions. I am considering the lotteries are as AI 1, AI 2, AI 3 for the overall set A. So, here I am mentioning AI and AJ as I did for the Tops's Electra method, Vicor method and all these things. So, when a lottery AI dominates AJ, dominance means the net worth which I am getting by utilizing the alternative AI or the lottery AI is more than AJ. So, it dominates AJ in the sense of first order stochastic dominance, then the corresponding decision would be to prefer AI with respect to AJ regardless of what utility function is you are using, as long it is weakly increasing. That means, the utility function is weakly increasing, and whatever the utility function we use, if it is that property, then the decision would always be to prefer a I with respect to a j depending on whatever the utility function is. Then obviously we will say it is first order stochastic dominance, that means a I dominance. In terms of basically the CDF values, because any of these utility functions would have an f of x, small f of x, which is either the PDF or the PMF, and correspondingly you will have a capital F of x, which is the CDF value. So, the PDF and the PMF are the probability density function, which is PDF, and PMF is a probability mass function. So, their corresponding cumulative distribution function would be mentioned as distribution functions or cumulative distribution functions only, and it is denoted, the second part is denoted by capital F of x. X is the random variable or the set which you are considering. Thus, in terms of CDF, if the functional form of x of f of x, based on the fact that you are taking the alternative or the lottery a I or a 1, whatever it is, because we are mentioning a I, so we will stick to a I, and if the CDF values for the other decision for that set of x based on the fact that you are taking the lottery a j. So, we will say that a I dominates a j if the CDF values for each and every combinations of x, f of a I would always be greater than or equal to f of a j. So, if I am trying to draw a graph, so let me draw the graph here. So, I am writing, let me use the colored black first. So, f and the case is a, let me mention is a 1. So, it will be easy for me to explain. Is greater than or equal to f of x for a 2. So, this would mean the concept of stochastic dominance which I mentioned. So, let us draw the graph. So, this is the value of 1, because the CDF value will always be is less than or equal to 1. So, it will go till its infinity depending on the x values. So, consider I am say for example, considering some fixed x based on which I will try to draw. So, if consider for, I will try to consider this is one value of x, this is another value of x, and this is the third value of x I am taking, and here I am drawing f of x, and this I am drawing the x values. So, this value of a 1 would be somewhere here which will dominate, because the sum I am taking the total area for each of them, and then if I consider the blue one, it is here. Similarly, if it is this, if this, the corresponding values are here and here. That means, the part of the distribution I am trying to draw very simply. So, consider it asymptotically goes to 1. So, this should be with a value of 1. So, this would never exceed. So, there is an area such that this would be, do I have a different color? Let me use the violet, or let me use the yellow would be much lighter, so it is easy. So, if you see here, the area of the CDF values for any value of x for a 1 and a 2, a 1 would always dominate. So, the area would be positive, it is not crossing, or it is maybe equal I have not drawn, but it is definitely less. So, in this case, why I did not draw the equal one is to make you understand. So, if you have this, so the CDF values for case of a 1 would be less, greater than A2. So, if I write it in the equational form, so integration, let me take any arbitrary x and it is considered I am starting from minus infinity, even though I have drawn it from 0 here. So, 0 to some x value f of x for A1 will be greater than equal to 0 to that corresponding value of x is same f of x, here I mention A2. So, this being true, you will basically have the concept of dominance which I discussed. So, let us see. Thus, in terms of CDF values, f of x based on the fact that I am taking the lottery AI, which was A1 there, and the other lottery which is A2 there in what I have drawn, which is AJ here. So, if AI or A1 dominates AJ, which is A2, it would imply that the cumulative function distribution for AI or A1 is greater than AJ or A2. Hence, it is this strictly inequality with strict inequality at some of the x's. There are some x's where it will be greater than, some it may be less than equal to. So, remember here x is an outcome. So, for different capital X values there are subsets. So, there are different combinations of x which you have. So, for some of the values is dominates is greater and some of the values is equal to. So, remember here x is an outcome and x is an element of capital X. Furthermore, AI first order stochastically dominates AJ if and only if every expected utility maximizer with an increasing utility function would always prefer A1 or AI with respect to A2, which is AJ, because the corresponding utility which I am getting for that decision would always be more in the former case. So, if I see the graph, this is what it portrays. So, now let us basically take an example. So, along the first row we have the outcome from the die, which is basically 1 to 6, and there are basically 3 lotteries which are correspondingly mentioned in row 2, row 3, row 4, which is lottery A1, A2 and A3, and the corresponding outcomes which you are getting from by rolling the dice. I will only read the row wise. For lottery A1, the values from 1 to 6 corresponding to the outcomes which I have from the dice 1 to 6 is given as 1, 1, 2, 2, 2, 4. I am mentioning the values, listen to it carefully. So, lottery A1, again I am repeating, would have values 1 for an outcome of 1 in the die, 1 as an outcome of 2 in the die, 2 as an outcome in from the 3 of the die, 2 as an outcome for 4 in the die, 2 as an outcome for 5 in the die, 2 as an outcome for 6 in the die. Similarly, the corresponding values for lottery A2 are 1 for 1, the next number which I am mentioning is basically the outcome of the die. Then it is 1 for 2, then it is 1 for 3, then it is 2 for 4. The first number again I am saying is which I am mentioning is the outcome. So, here it is 2 out of 4, 2 for 4, then it is 2 for 5 and 2 for 6. Similarly, when I have lottery A3, the corresponding values are 3 for 1, 3 for 2, 3 for 3, 1 for 4, 1 for 5 and 1 for 6. Now, if I want to consider, let us consider one by one. One is strictly the first order dominating strict sense and in the non strict sense. It is not strictly dominating first order, sorry, first order dominance. So, let us consider 1 and 2 basically. So, equality holds 1 and 1, 1 and 1. Now, if I consider A1 has started dominating first order because the value is 2. So, if I find out the corresponding CDF values, so 2 is corresponding to 1 is more, then it has already started dominating. So, 2 is would be more than 1 if I add up all the values from 0, 1, 0 means 1 till 2. So, the values from 1 to 4 correspondingly it is 1, 1, 2, 2, here it is 1 1. So, equality holds here, equality holds here, it dominates, A 1 dominates first order wise. This as the dominance has already started. So, this will keep repeating and get much more dominance would become true, but if the dominance appears in each and every stage individually also. It is equal, fine, equal, fine, equal. So, in general it is greater than equal to for equal to sign for holds true for 5 of the cases and greater than sign holds for 1 of the case. Now, let us consider A 3 and A 2. So, A 3 it basically means that 3 is better than 1, 3 is better than 1, 3 is better than 1, 1 is here, but you have already taken the cumulative value. So, remember that. So, here is already cumulative value, cumulative value. If I take it, so obviously in the cases the first order stochastic dominance holds. So, if I read, it means here A 1 as well as A 3 dominance A 2 in the first order sense, while nothing can be said about the dominance of A 1 and A 3. So, let us come why. So, let us first mark. So, this dominates this and A 3 also dominates A 2. So, if I want to write, it will be A 1 A 2, another is A 3 A 2. Now, let us consider the other case of A 3 and A 1. So, if it is A 3, I find out that some of the values we have is, wait, let me check the values of A 1 and A 2. So, it basically is dominating, in the next case it gets reversed, 2 is greater than 1. So, and the cumulative distribution values which I consider would not be coming the same. So, they would crisscross. So, if I have this one, let me go to the slide where I have drawn the diagram. So, if this green blue one was like this I will erase. So, see for example, this blue one is this what I have done. So, it basically crosses this and then again comes here. In this case dominance would not hold to first order, because in some of the cases it is greater, some of the cases it is less. Let us consider the second order stochastic dominance. So, in the second order stochastic dominance, we will see a lottery A I will dominate A j in the sense of second order stochastic dominance. Then the decision maker prefers A I with respect to A j as long he or she is risk averse and the utility function u of x is weakly increasing, and that holds true. In terms of the CDF values, a second order stochastic dominant concept would be written. Now, you will take the second integration of the CDF value. So, CDF value was basically the integration of the PDF of the PMF. Then for the second order stochastic dominance, we take the cumulative function of the CDF values already taken. So, if I consider this, the first part I will mark it with a orange, this part. So, and with the integration time sign, it f of A I would be okay, should be dominance. So, obviously, it should be 1 I. So, in this case if A I would dominate A j, if the integration. So, what I have to do is this would change, I will mention it. Integrating this. So, if I use the color say for example red, 0 to same values which I am doing for the integration f of a to x. If this is greater than equal to 0, that means the cumulative function of ai's each and every step from 0 to x is basically sum is greater than the a2 value. So, I am taking the CDF value, then again integrating and summing up the values. So, in that case if this holds true, it is not the second order stochastic dominance. So, remember here x is an outcome and x is capital small x is an element of capital X. Expressed using utility function, the second order stochastic dominance can be expressed as the concept where the expected value for the utility function a I is greater than the expected value for the utility function considering a j. So, to continue the further discussion, in consumer concept of the utility which you are getting, or from the point of view of production economics or production or welfare theory. What is the wealth? Wealth means in the sense of the total welfare with a person or decision maker gets. Considering that if you have two distinct sets which are element of capital X, I am denoting these vectors by small x and small y. Elements are for each x is from or y is from x1 to xn, and for y it is basically from y1 to yn. So, if x is better than y, then at least for x at least as much, or the net worth which you will get is as good, or it will provide the at least the same amount of wealth, or wealth wise it will be greater than or equal to y. So, if this particular holds for the consumer, you will basically have at least as an amount of good as it accrues to y. So, x value you will get on the goods front or the net worth front is more than that what you get for the goods or value on for the fact that you utilize the vector y. Similarly, if I come considering from the production concept, production economics, so it will provide x will provide at least as much as the output as y. It can be more than y also, but at least it will maintain that. And from the concept of welfare theory, so the total wealth wise it generated would be more in x at least at to the level of y. So, this will hold true. So, in the first case we considered, so let me go to the graph. So, here was the CDF value which is the first order. In the second case what I will consider is this, I will draw this diagram, it will be easy for you to understand. So, consider the expected value of the red area is somewhere here. So, the PDF you have, let me redraw it, at least draw the PDF. So, consider the PDF is there. I am drawing in a very informal way in order to make you understand through the graph. So, consider the PDF is this, from based on which you get the CDF, which is the red line. Consider this is this. For the green one or the blue one, it is somewhere. And also assume the expected value. For the red line, the expected value center of gravity is, I am marking as the red color, and for the blue color it is here center of gravity. So, as the expected, okay, and this is E. So, if I have this holds true, so this is the second order, and this holds true, this will be the first order. So, generally the rule for the stochastic dominance will be this. I will discuss it later on more in the multi objective decision making case. With this I will end this second class in the 9th week and consider more discussions later on accordingly. Thank you very much and have a nice day.